2019 paper 2. We're now on question 7. The triangle has one side of length 10, another side of length x, and the perimeter triangle is 29 centimeters length. Find the length of the third side. Well, if we get your 26, we take away a 10, take away a 4, we get an answer of 12. So that would mean that's 12 centimeters. Okay. Then diagram B, the same thing. 26, take away your 9, take away your 10, because you have a length of 10 centimeters and 9 centimeters, means the third side must be 7 centimeters. Okay, so that's all good there. Okay, nextly moving on. Find 3 values of x that will make x an isosceles triangle. That makes the triangle an isosceles triangle. Okay, well, the first thing we could do is we could say that, I'll use this diagram B as an example. I could say x is 10, and if they're both 10, then it'd be an isosceles triangle. Okay, second answer I could go for would be, so it has to be isosceles. So what happens if we were to make this one 6? Well, that means the remaining side is 10. 10, 10, and 6. So 6 centimeters will also work. Okay. Now we could also say that this side is 12. That side is 10. That's 22. Now, what can we do? Length of the third side is 7. Okay, guys. So imagine on this triangle we made this 8 centimeters. Once again, it has to add up to 26. So 8 plus 10 is 18, plus 8 is 26. So this one would also be a isosceles triangle. So the other answer is 8 centimeters. Okay, let's keep moving on with part C. The graph below shows the area of a triangle for all values of x between 3 and 13. The point A is marked. A is the point of the graph with x equals 4, represents the triangle in diagram A. Use the point A on the graph to estimate the area of triangle in diagram A. Okay, so let's estimate this triangle. That's the area of this triangle. So we get our graph here. We draw a straight line going upwards to A. Then we can draw a line going straight across. Now, somewhere in between... suppose what we at, that's 16, 17, 18, I'd say around 18.5, 18 and a half. Seems to be halfway between the 18 and the 19 here, okay? So if I was to zoom shot that a bit closer, usually makes it a bit bigger. We can see there, halfway between 18 and 19. Is that okay? Okay, brilliant. Now, let's move on. Okay, plot the point B on the graph to represent diagram B, label the point B. Okay, so x equals 4 was diagram A. This means x equals 9 must be diagram B. So where's x equals 9? And we can see that x equals 9 seems to be quite a large amount. So 9 is up here. We can call that diagram B. There we are, roughly there. There's diagram B. Okay, nextly, label the point B. Done. The graph is symmetrical. Draw the axis of symmetry. Write down the equation of the axis of symmetry. So an axis of symmetry, if you will, if we had a shape like a standard rectangle, the axis of symmetry is where you can fold it. It goes straight down the middle, or you can go straight across. Okay. Now, in a rectangle's case, there's 2 axes of symmetry. In the likes of a circle, there's infinite amounts of axes of symmetry, provided they go through the center of the circle. Let me explain. So here is an axis of symmetry for the circle. So anything that goes through the diameter should be an axis of symmetry. You see, anytime you fold any of these, it will fold directly in half. Now, with the curve here, what we can say is the axis of symmetry is on this part here. You can see half the shape is to the left and half the shape is to the right. A bit like an insect's body, okay? So this is a vertical line, and each point on the line, the x value is 8. This is the line x equals 8. Okay, you guys? X equals 8. Okay, next question. D. When x equals 5, the triangle has sides 10, 5, and 11. Show that this is not a right angled triangle. Well, to show that a triangle isn't right angled, we get the longest side, which would have to be the hypotenuse if it was a right angled triangle. And what we do is we do Pythagoras' theorem. If Pythagoras' theorem doesn't balance, it means that it is not a right angled triangle. So 11 squared, does it equal 10 squared plus 5 squared? Well, the answer is no. 121 does not equal 125. Therefore, this is not a right angled triangle. Okay, next one. The diagram below shows the triangle with the biggest area. 8, 8, and 10. Work out the area of this triangle and give your value in x root n. Now this is a what's it called? This is a isosceles triangle. Because it's a isosceles triangle, what we can do next is we can half the 10. So this works for equilaterals and isosceles. And now we're going to figure out the height, because the area of a triangle is a half base times height. And what we know already is we know the base is 10, but we don't know what the height is. So we're going to try and figure out the height using Pythagoras' theorem. Okay, so when using Pythagoras' theorem, we're going to use 8 squared is the longest side, so it's going to be 8 squared equals 5 squared plus h squared. And then what we're going to get is 64 equals 25 plus h squared. 39 equals h squared. This implies that h must be root 39. Okay, next thing after that is we're going to do a half base times height. So it's going to be a half your 10 multiplied by your root 39. And our answer is going to be 5 root 39 centimeters squared. Okay, hope that holds it out for you guys. Okay, next question. A net below is folded to make a fair die. What number will be opposite to 7 on the dice? Okay, so this is a great video here about box folding. Okay, so what we can have here is we just pause it here. Okay, and what you can see is that this blue one, light blue or turquoise, is going to be opposite this one here. See the way there's a distance of 1, there's 1 in between them. Okay, now this one here, the navy one, is the base, and it's going to be opposite something that's a distance of 2 apart from it. So the white one is actually on top of the dark navy one. Okay, and if you look at other examples like this one here, which is similar to the question we're being asked, this blue one here, okay, well, it's going to be opposite, oddly enough, it's going to be opposite this turquoise one here, because it's going to fold up this way. So I'll show you now. And this dark navy one will be opposite the white one. Okay. And then this one here will be opposite this one here. So just look at it there. You can see how that works. Okay. Now we try and take that to what we know. And this one here, well, 1 will be opposite to 7. So the answer is 1. A die is rolled once. Find the probability that the number is greater than 6. Well, 7 and 8, which is 2 numbers out of 6, greater than 6. So, how many sides is there? 1, 2, 3, 4, 5, 6. So, 2 out of 6, which is 1/3. 2 chances out of 6, which equals 1/3. Okay, next question. The die is rolled 60 times. How many times would you expect it to be an odd number to be rolled? Well, 60 multiplied by the probability of getting an odd. How many odds do we have here? Well, we got 7, we got 5, we got 1 and 3. That's 4 out of 6 of them are odds. So multiply that by 4 out of 6, and you should get an odd 40 times. That's what you expect to happen, but doesn't always happen that way. Okay, next one. The following 3 terms are used when discussing experiments and probability. Which one is which? Well, so sample space is the set of all possible outcomes in the experiment. One possible result of the experiment is an outcome. And finally, a subset of the sample space is an event. Okay? So as an example, if you were to toss a coin twice, you could have head, head, tail. You could have tail heads, and you could have two tails. Okay? Now that would be your entire set of, so if you imagine it in a set like this, okay? So that would be your entire outcome, like so. Okay? So all these outcomes would be in here. Next thing is one possible outcome would be a subset of the sample space. And a group of outcomes, for example, how many of them have at least one head, would be the three of these. And once again, you can see that that's a subset of the sample space. Okay. Now, Jar flips a coin 3 times. Each time it gets a head or a tail. Complete the table below by doing each of the following. Write in each of the missing letters H or T in the diagram and fill in the 5 missing outcomes. Write the number of heads in each outcome. Okay, let's do this. So we're obviously going to make this a lot smaller. Okay, so this is relatively easy. Head, 3 heads. Okay, next one, head, tail. That's 2 of them. Then we have head, tail, head, which is 2. Head, tail, which is 1 head. Then we get a tail on the first row, head on the second row, head on the third row, tail, head, which once again has 2 heads. Tail, head, tail, which only has the 1 head. And then tail, head, which has the 1 head. And then finally tail, which has no heads whatsoever. Okay, fill in the probability. Probability of getting 0 heads. Well, that's 1 out of 8. Only one outcome out of 8 had that much. 1 head will be 1, 2, 3. 3 out of 8. 2 heads will be 1, 2, 3. 3 out of 8. And finally, 3 heads is the maximum, will be still 1 out of 8. Okay. Philomena flips a coin 8 times. Each time she can get heads or tails. Write down the number of outcomes that have no heads. Okay, so she does it 8 times. The probability of her getting no heads is 1 in 8. So 8 times 1 in 8 is 1. Okay, part 2. Work out the number of outcomes that have exactly 1 head. Okay, she tosses the coin 8 times. And she multiplies by, well, if you flip a coin 8 times, the amount of outcomes are going to have exactly 1 head is going to be multiplied by 3 and 8, which is the probability of getting 1 head, as we see above, which would be 3 outcomes. Okay, and finally, part D. Work out the total number of outcomes and fill them in if it flips the coins 8 times. Well, look, it's the rule. If you flip it twice, if you flip it once, there's 2 outcomes. Flip it twice, there's 4 outcomes. Head, tail, head, tail. 3 times, you get 8. And then if you flip it 8 times, it's 2 to the power of 8, which will be 2 to the power of 8, which is 256 outcomes. Okay, work out the circumference of a circle with diameter 8 centimeters. Well, circumference is 2 pi r, diameter is 8, radius is 4, c equals 2 pi times 4, 8 pi. .13 centimeters. Which is 25.1 centimeters. Oh, sorry, 25.1 centimeters. Yep. Okay, 4 centimeters. So what do we get here, guys? So we gotta find basically the length of the track around the edge. So remember, two semicircles, which are the two red areas, they should come together to form one circle, like so. Poorly drawn circle, but circle nonetheless. This circumference of the circle is 2 pi r, and we know that the radius of the track is 4 centimeters. So we go 2 pi times 4, which is 8 pi. Now the next part is going to be the yellow part here, which is here and here. So what we're going to get here, guys, is 8 centimeters from here to here, 8 centimeters from here to here, and 8 centimeters from here to here. So we can see that these are actually the same length as the yellow parts. So that's 24 there, and that's a 24 there, so it's 224. So it's going to be 24 plus 8 pi. Throw that into the calculator. So not 24 plus 8 pi, 224s plus an 8 pi. The two yellows are 224s. That's a 24, that's a 24. 24 plus 8 pi, which is 73.1 centimeters. Okay, we all good? Now, every time the wheel turns free, the digger travels a distance equal to one of the wheel's circumferences. Okay. Work out how many times each wheel will turn fully when the digger travels a distance equal to the length of his rubber bands. So, what we got to do here is we got to get the total distance it travels. So the whole rubber band itself will be 73.1 centimeters. Okay. Now, it takes one turn is 25.1 centimeters. That's the circumference of one of the wheels. So the number of turns will be 73.1 divided by 25.1, which equals 2.9 turns. We all good with that? Okay, question 11. Okay, so how are we going to do 11? So we're going to try and chop it up into two. We need the area. Okay, so I'm going to make a line here, incision. Now, this is S, so that's the length of S. So S plus something has to equal 6, so this one must be 6 minus S, because S plus 6 minus S is 6. Likewise, if this is S, then this part here must be 10 minus S. 10 minus S is the distance between the two blue points, and 6 minus S is the distance between the two green points. Now we have two rectangles to work with here. We have the area of the pink area, which I'll call here, and then the area of the green area, which I'll call down here. Okay, so it's length times width, which is going to be s times 10 minus s for the top shape. And then for the bottom shape, it's 10 times 6 minus s. Going to multiply it out, and we get 10s, and then s times minus s is minus s squared. And then the other one is, so that's s times 10 minus s. So this is, the next one is a length of 10 and a side of 6 minus s. So it's going to be 60 minus 10s. Going to add the two of them together to get the total area. So quite simply, the 10s's will cancel, and you're going to get an answer of 60 minus s squared. Okay, and that's your area of your full shape. Show that or explain why the perimeter of this shape is always 32, no matter what the value of s. Well, we're going to add up all the sides together, and what we're hoping for is that there will be no s in the answer, which means the value of s never affects the perimeter. So we send it to the current page. Okay, so let's add all these sides. Remember, perimeter is when you do a lap of the outside area. So that's what we're going to do. Okay, so we have 10 plus 6 minus s plus s plus another s plus 10 minus s, and then from here to here will be a 6, because s plus 6 minus s is 6, and then we start off with the 10. So let's see if all the s's cancel. Minus s plus s plus s minus s, no bother. 10 plus 6, 10 plus 6, 32. Will always be 32. Perimeter value is independent of s. Means it doesn't have an s in the answer. So if this was 32 plus s, it wouldn't be independent of s, it would have s in it. Okay. Now, we got a proof here. Proof that each exterior angle of a triangle is equal to the sum of the interior opposite angles. Okay, guys, so we got a little proof here, so best to do it now and you can learn it for the junior cert. Okay. So step one, draw yourself a triangle. And then draw yourself an angle, three angles. Label them any way you want. I'll call this A, B, and C. And then the other one is going to be D. Now what we want to prove is that angle D equals angle B plus angle A added together. So what we're going to write down is to prove, where's this part here? It's not in the given step yet. Oh, sorry, it's in the given step. So we have to write the given is given a triangle with angles labeled A, B, and C. And D, okay. And we want to prove angle A, the size of angle A, that's what those vertical lines mean, plus the size of angle B must equal the size of angle D. Okay, so, oh sorry, that's to prove. Reload that down there. Okay, there we go. Now, next step, proof itself. Well, if you look at the three angles here, angle A, B, and C must add to 180. So, angle A plus angle B plus angle C, now those vertical lines there, must equal 180 degrees. Reason being is angles in triangles sum. Three angles in a triangle add to 180. Okay, next one after that. Then we say is angle C plus angle D. And if you look at angle C and angle D, they're in a straight angle together, equal 180 degrees. Reason, angle in a straight angle is 180 degrees. Next one. Step 4. If they're both equal to 180 degrees, this means angle A plus angle B plus angle C have to equal angle C plus angle D. Now cancel the angle C's off both sides. Now you don't actually visually do that, but you can write down, look, angle A plus angle B equals angle D. So this is what we're asked to prove, and we're done. Okay, next part. Use trigonometry to work out the value of x in the diagram below. Give your answer correct to 2 decimal places. Well, we got Sokotoa, Silly O'Harry, Chase a Horse, Chew Attic. We know the opposite because that's the side that the 20 is looking at. And we know the adjacent is x. So now we got tan 20 degrees equals 6 over x. Cross multiply up the x up to the tan 20. So x tan 20 equals 6. And then x equals 6 over tan 20. And then x equals 16.48 to 2 decimal places. Okay, we're done. Now, this one here on different. Just get rid of that bottom there. Very professional, Mr. Kenny. Now we fill that in, and then fill color. The fill color out there. There we go. Done. Now, in this triangle, A plus B is bigger than C. Okay, that's standard. That any two lengths in the triangle have to be larger than the third side. Any two sides have to be larger than the third side, otherwise it doesn't form a triangle. Prove that cos y plus sin y is greater than 1. Okay, so here's what we'll do. We'll write down cos y is A over C. Sin y is B over C, which is opposite over hypotenuse. So is A over C plus B over C. Now, is it greater than 1? Well, give it a common denominator. So I could change 1 to C over C, cancel the denominator, and then I get A plus B is bigger than C, so hence it's true. No bother. Okay, question 14. A cylinder has a radius of r and a height of 10. The cylinder is melted down and made into a cone. The cone has a radius of r and also has a height h. 10% of the volume of the cylinder is lost during the process. Work out the percentage increase in the height of the cylinder when it's made into a cone. Now, cylinder has a radius r, like so, and a height of 10. The cylinder is melted down and made into a cone that also has a radius of r and a height of h. 10% of the volume of the cylinder is lost during this process. So let's get the volume of a cylinder. Volume of a cylinder is pi r squared h. In this case, it'll be pi times r squared multiplied by 10, which is 10 pi r squared. Now remember, that's 100% of your cone, but you lost 10%, sorry, 100% of your cylinder, so you lost 10%, which means you need to get 90%. So divide by 100, multiply by 90, and you get 9 pi r squared. So when you lose 10% of that, you lose a pi r squared. Now the volume of your cylinder, which is a third pi r squared h, must equal 9 pi r squared. So what we're going to do here, guys, is we're going to cancel the pi r squareds off both sides, and then we're going to find out that the height is 3 times 9. Division of 3 on the left means multiplication of 3 on the right. Height equals 27 centimeters. Now it's asking me the percentage increase in the height of the cylinder when it's made into a cone. Well, the increase, excuse me, is 17 centimeters because it was 10, now it's 27. Its original size is 10. I need to multiply that by 100, so it's going to be 170%. Okay, and look guys, that's us done. 32 minutes.